All right, good afternoon, sixth graders. Hope you guys are having a good time. This is Mr. Hale here. I'm going to keep going on our idea about plate tectonics and go into our second unit, which is going to deal with how do these land formations actually get formed. We talked a little bit about it in the last YouTube video. Now let's go into how those landforms are created. So that's our section for today. How do the Earth's plates create landforms? We're going to talk about continental drift in a second, how Pangea formed. But let's talk about this driving force. This driving force that forces those plates. Remember these plates up here that we talked about? We talked about these plates right here. That forces these plates to shift around. These plates are constantly shifting left and right and moving. And they've moved from this area, from being Pangea, where they used to be one big continent 225 million years ago, and slowly breaking free. That convection cell is constantly breaking them up, moving them around. Well, what causes these things to move? They move around until you get to the present day North America, Africa, Asia, and so on. So how does that happen? We have this thing called a convection cell, the spreading of the sea floor. Now, I'm going to get you to another picture so we can talk more about this, which is over here. Okay? So here is a picture of our interior part of our planet. Okay, we remember before we had the inner core. We have the inner core that's here. We have the outer core, nice and hot. We're going to call this really hot. Nice and hot. As it hots, certain parts of it starts to boil up, and the magma starts to move higher and higher from this mantle. Then it gets up to the top. When it hits, it starts to spread out and gets pushed to the side. When that pushes to the side, it actually cracks. It's like if you take your skin and try to peel it apart, it actually cracks down the middle. And here's this crack where the ocean actually is ripping open, almost like a scab being ripped open. The whole ocean is starting to rip open. Okay, now this is pushing the plates this way and this way, which start to separate the ocean. And this is actually the Atlantic Ocean, if you want to look at it. The Atlantic Ocean's getting bigger. This over here would be Europe. This over here would be North America, and they're actually getting farther apart. We don't need that for right now, but the oceans are spreading apart. In the middle of the Atlantic Ocean, there's this big spreading center called the Mid-Oceanic Rift that's ripping apart and separating the two continents. But if that's separating, other parts have got to be colliding and going and disappearing. So as that starts to cool down and this stuff starts to come over this way, it starts to cool down and starts to get pushed underneath. When it cools down, it takes some of the continent with it, and it starts to collide down and pulling it down. As that happens and pulls down, notice we have this right here. That's basically the formation of a volcano. As this thing starts to melt, there's a lot of friction that forces it to melt and bubble up. We'll talk more about that later. Okay, but this is how mountains are formed. Look over here. We have a continent being pushed up because of that collision. One continent's colliding this way, another continent's hitting this way. When they collide, they form this mountain range that forms over here. So over here, there's a mountain range that's forming too. If you look, two things that are colliding together before the magma starts to push it back underneath. So this is how our planets are formed, and plates are moving left and right, trying to compensate for that bubbling effect. Sorry, turn the picture off. Let's go back to our things. So that's what happened here. 225 million years ago. Okay. We had the Permian. Don't worry about the Permian, but we had this big continent. It was all together as one called the Pangea. It's not the first time it's happened. It's happened about 5 times before this. But this is the latest one that's happened. It's called Pangea. One supercontinent. If you look closely to the left, where P and A is, that is where South America is. N is part of Africa. G, A, E, and A, okay, that makes up Europe. Just above where G and A are, that's North America. You can kind of see Alaska up there. Okay, you can, if you look close enough, you can see actually Madagascar. To the far right, to the bottom far right, that's Australia. Now, over time, as that bubbling effect started to take effect, the plates started to shift around each other. They started to break up. Okay, each one having its own little bubble and moving the continents away from each other. When that happened, we had 2 subcontinents. The north one called Laurasia, which was part of North America and Asia. Then you should easily be able to see now South America and Africa as well as Antarctica and Australia. And there's this little island starting to form called India. Those things make up this thing called Gondwana land. And India actually used to be an island. Okay? Now, the things keep moving. Okay? To the right of Africa is India. Just below India is Australia and Antarctica. You can start to see North America kind of forming. You see Mexico and Florida, that little hook of Florida coming off, and you see South America. Now, about 65 million years ago, the continents keep spreading. And it keeps spreading. Now you can start to see it. Now, India still is an island. And then to present day, we have India by itself now smashed into Asia, North America, South America, Africa. Guess what? This process is going to keep going. Our continents are going to come back together again and smash together again in about 250 million years. Now, what is some evidence that supports this? How do we know this actually happens? There's a lot of evidence. If we look down the middle to the right of Africa, North America, and to the left of Africa, the fossils that we find on the Atlantic side of North America are the same fossils we find in Africa, on the west coast of Africa. How do they have the same fossils when they're that far away? South America, same thing. They share the same fossils in South America as they share in Africa. How could animals that far apart? People talk about land bridges and Atlantis and, journey to the center of the earth, and that's all cool, but that's some evidence that supports that the continents were used to be together and slowly separated. So we have the evidence, we have the driving force, and we have the motion of the plates. So hopefully you guys enjoyed this. If you have any questions, make sure these are times where during the Zoom sessions, you get a chance to ask me questions about what you didn't understand. So till the next time, this is Mr. Hale signing out. KD2 LPM for K2.